Welcome back. In this unit 2.5, which is specific to chapter 5, we'll talk about data errors. Just to give a bigger picture, in the last unit we talked about identifying and obtaining data. And once you obtain the data, you'll download the data and you'll try to evaluate the data and try to clean it up so it is ready for the next section or the next step, which is analyzing data. And we'll talk about analyzing data in the third unit. For now, in this unit, we'll talk about evaluating data and cleaning data. In unit 2.5, we'll talk about what data errors mean and how to identify them. And in 2.6, we'll talk about how to check for integrity of the data. So data integrity. And in 2.7, we'll talk about how to shape your data, make it ready so you can analyze it. So in this unit, which is specific to chapter 5, we'll first, in the next section or the next slide, we'll talk about the introduction of what data errors mean, and we'll talk about dirty data next, then detecting dirt in the data, followed by understanding the fact that uh, data errors comes from changing rules. And finally, you'll have an option to actually work on some applicational practice exercises. So let's move on. In the next slide, we'll talk about the introduction to data errors. Okay, so coming to the introduction, data errors. Once you download the data that you've identified, remember we always start with a question. You have a question and try to find an answer to the question by searching for, identifying, and obtaining specific data. Now, everything starts with a question. First, you have to evaluate if the structure of the data and the bare minimum information that's in the data is sufficient for you to answer that question. The problem is that you cannot just blindly trust the data. The data you get even from the government agencies is not trustworthy because there could be errors at different steps and different levels. You need to know inside out of the data that you have downloaded so that first question you ask is, can the data answer the question I started to ask in the first place? Then you think about, is this data that I have to answer this question I have in the initially, is it sufficient or do I need more? And also, even if you think it is sufficient, the question is the data in the usable format? Does the data have all the information that you need to be able to answer the question? In that sense, what is the strength of the data? What are the weaknesses of the data? And what are some missing information in the data? And is the missing data really critically important? If not, then you need to figure out another way to get another set of data so you can eventually answer your question. So remember, it always starts with a question. Now, here is another thing. You need to follow the ethics of the field when you are using data or trying to answer some questions in the data or to summarize the data. Because whenever you report the data, whenever you're using data and trying to make some meaningful inferences from it, you are making some claims. And you need to be very, very, very cautious to make sure the data that you're using is in the right format, sufficient for you to answer the question in the first place. You cannot just blindly use the data. Because whatever inferences you draw or the answers to the questions you started with, these answers rely so much on you as it depends on the actual data. So the information you're giving to the public have both positive and negative impacts, right? And it's your responsibility to make sure that the conclusions you draw from the data, which have these positive and negative impacts, the conclusions are true. So that's why you need to evaluate the data before you can set out to analyze it to answer the question. So this is the basic step of data literacy. This is a basic step of going from question to answer. You need to thoroughly understand and evaluate the data that you have gathered. There are several reasons why um, the data that you've downloaded from the agencies may not be reliable and accurate. So just because you're collecting data from the agency does not mean that it's accurate. Well, it may not necessarily be intentional. There is so much data that is gathered in by these organizations that they don't have the infrastructure or resources to check the quality of the data or to check for any errors. There is a room for error in just as simple as entering data, or there could be some technological errors. The problem is that government agencies do not have or a good quality control measures to look for errors in the data. So the onus is on you then when you get this data to evaluate it. One simple example that your book talks about is to find the outliers. Any information that is glaring at you, showing you that it can't be true. It's probably not true. So you need to find such outliers. Outliers are one good indicators of errors in the data. So your book talks about this data set, and you can pull this information from right here in this using this link, where this particular elementary school from California, which has 654 students, it is required to report the cases of students being sent back to home for reasons. They also need to provide information about why. And what it said was that in the year 2010 and 11, this particular school reported that um, they suspended 306, almost half of the students, for bringing guns to school. I mean, that doesn't sound right, right? And later it was that's clearly an outlier. So you need to look at the specifics of the information, try to make a general sense of, well, is it even possible? So finding outliers is basically an indication that there is some error in the data. um, as someone said, data finding errors in data is a norm, not an exception. Okay, so in the next slide, we'll talk about dirty data. Well, dirty data is another name for errors in the data. We'll talk about the sources of these errors and how to identify these errors, and we'll do that in the next slide. Well, coming to dirty data, the question is, where do these errors come from? Keep in mind, these errors in the data is a common occurrence. So that's why I say all data are dirty, period. In other words, there is some error in any data you take unless it is already evaluated for you. If you're collecting or downloading and looking at raw data, it is most likely infested with errors, um, because there are no quality control measures. Even if there are, the measures are poor. And there are no specific reviews of the data that the agencies actually do to make sure the quality of the data is reliable. Well, now the question is, where do these data errors come from? Well, remember we talked about what are the indications of the data? We said that input and output. These are two ways you can make some guesses about the data. Well, these are the two sources of the data as well, especially input data. So when the data is inputted, right, when it's input in a paper format or an online format, um, then there is a chance of error in entering information. Let's say most of the government agencies, they take paper format and convert the information into an Excel sheet or some sort of program. So they have to type that information in. For instance, they're typing my name. Oh my God, there are chances that they will definitely make an error when they type my name. Does it make sense? So that's a very simple error. Another example would be, let's say, um, different ways of writing a common name. For instance, name of the street. In some instances, the clerk may put AV for avenue or RD for road. And second time, he or she may actually spell it out, right? So in those cases where the information need to be same has changed, right? The problem with that error is that your spreadsheet, when you try to see um, how many observations have a specific street address, then it will try to categorize each of these different versions of the word RD and ROAD as two unique entries. Actually speaking, this is a short form for road, right? But the spreadsheet will not consider that. So that is an error in itself if you don't pay attention to it. Because spreadsheet takes each entry as a unique value, even if there is a small difference in comma or something. So one way to fix it is to use these online forms which have automatic built-in error checking tools. And it's not common to find them though. The other option that designers do is not give the option to enter manually the data, but to actually check the options, right? If you have a question and you need to just select the option as opposed to writing the name of the street, maybe you can browse through the name of the streets in a given city that you're collecting data for. So that would be another fix for it. One way to think about data dirt or the errors in the data is the format in which the information is stored or how the information is stored in the columns. For instance, let's take this example. Let's say you have a data set and it is collecting information. The first column represents information about the name, maybe the second column information about the contact information, third column maybe about the date, and so on and so forth about a specific thing. Now, the the format the information is stored is important. Um, and what it means is whether the information is one common example is the dates, right? The different ways of putting dates in the Excel sheet. The format could be something like this, where you have 12 January 2007, or the data format can be of this sort, or the data format could be in, say, 2 plus 2 plus 4. 10 digits. The first two digits are month, second two digits are day, and the last four digits are year. Then the question is, the format in which the information is stored will determine how well you can utilize it for different purposes. So the error could just be the format in which the information is stored, right? So some formats are flexible, some formats are not. So knowing the how the information is stored in the particular column is also important. So we're talking about the data design related errors. One thing we said is the format in which the information is stored would make it either flexible or not to how you can um, run the analysis or answer questions. The other form of data design related errors is run on data. Um, the example for run on data, what run on data means is that um, let's say the information about uh, what do you say um, a ticket that you reach, the speeding ticket, let's say. That information is gathered. And if you look at the form, you'll see the name, date, time, blah, 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 your address, and everything else. Just imagine if that data, when it is entered into the system, let's say it's manually entered into the system, and the person who's entering the data is putting all the contact information in just one column. For instance, the street address, um, then the zip code, then the state. All the information is stuffed in one column. Ideally speaking, you would like to have several columns for this information, one column specific to one information. The street address would be one, the zip code would be one, the state would be another. But if you try to stuff everything in one column, you call that run on data. Why is it a problem? Now let's think about. Let's say you're trying to see which zip code has the most speeding tickets. Well, you cannot run this data based on this data structure because you cannot isolate this particular zip code. You only have the entire contact information in one column. So there is no way to run the analysis just on zip code. So you cannot answer that question. So, and again, there are ways to fix it. We'll talk about that. How to break the data, parse the column into several columns that would help us fix it and make it, clean it, and make it in a way that you can actually use it to analyze the data. Okay, let's move on to detecting errors or dirt in the data. Okay, now this is kind of weird. I'm not going to discuss what is discussed in the book on this topic of detecting dirt in agricultural data. It's a very short paragraph. I want you to read it and try to summarize what you've understood from this particular thing. I know this is not for any grades or anything. This is just to keep the conversation going. What did you learn about detecting dirt or errors in agricultural data? This is in chapter 5, and you'll find it. I have a text version of it, so the electronic version of it, so I can't give you the exact page number. I think it's like 71 could be the page number, but it basically says detecting dirt in agriculture data. So read that and kind of give a quick summary of it, or what you think have you understood about this particular section. You just need to click on this plus button and add your comments. Okay.
This is my summary of what I understood and what I learned about detecting dirt agricultural data from the paragraph in our data literacy book. To gain an idea and to create predictions about the world's agricultural activity, the Food and Agriculture Policy Research Institute, or FAPRI for short, obtains data from both the U.S. and foreign government agencies. When FAPRI analysts receive data, they comb through it looking for errors that need correcting. To better spot the irregularities and keep the data stable, they create Excel spreadsheets of the data, ensuring the sum of the production and imports equals to the sum of domestic use, exports, and ending stocks. Sometimes price data information is missing, so analysts must decide on how to fill those missing values. With every so often, the data can be revised by the provider. Though most of the FAPRI receives its data online, occasionally data must be entered manually for, from published reports or from information obtained by a phone call, which can lead to human error.
Detecting dirt agricultural data. The Food and Agricultural Policy Research Institute get their data from all sorts of sources. Each of these sources alone could be laden with errors of every kind, from foreign sources which may deliberately skew data to taking data over a phone conversation. There's also the possibility for errors to occur as the information is being entered into spreadsheets, etc. Basically, to summarize it, the more sources there are to enter, the more likely the chance there is for errors to occur, and the more it becomes necessary to scrub the data for any such errors.
Okay, in the next slide, we'll talk about how changing rules means changing data, which is equivalent to data errors, which is nothing but data dirt. Um, so that's what we'll talk about in the next slide. Okay, so another form of source of error in data you'll see is a change in rules after starting collecting data, which is equivalent to change in data itself. Um, let's take an example. Um, the Bureau of Labor Statistics layoff collection started in 1995, which kept a note, a record of the number of layoffs in both private and public sectors starting 1995. Um, and they suddenly changed the rule in 2004 to exclude data about layoffs from public sectors and especially agriculture sectors. So what happens then is that the data structure might be same, but given the rules are changed, the information from 1995 to 2004 would involve both private and public sectors. But starting 2004, the information only has information about layoffs specific to the private sector. So if you're trying to compare the layoffs before and after 2004, well, there is a discontinuity, right? Because you don't have public sector data beyond 2004. They have changed the rules. And changing the rules doesn't imply who from whom you're collecting their data. That may also imply the way you're collecting data. For instance, you may add some additional information or take some information off from the first time you've collected data to the second time you're collecting data. Okay, so then these two data structures from two different times would not yield the same information. So there will be some difficulties or impossibilities to compare the data from one time to another time. Let's look at another example. The Department of Housing and Human Services, it collects data specific to the um, estimates of cost for health insurance premiums, specifically the employer-based health insurance. Um, and they estimate the costs each year, and so they make some predictions about where the direction, how it is changing, and what the factors are that led to change in these things. But what happened in year 2007 is that it took off. It paused its data collection in 2007 with an intention to, what do you say, to standardize the methods or to revise the methods to make it better. That led to a situation where you don't have data for 2007. So that would be another example of tweaking data collection rules. So to conclude then, dirty data, in other words, errors in data, is not an exception. It's a norm. The errors can range from simple typos to changes in the data structure itself or errors in the data structure itself. It can go from simple errors to big mistakes. The dirt may represent simple errors to big mistakes. The question is, what can we do? How can we fix this? Well, we need to perform integrity checks to determine how bad the data is or how dirty the data is. And that's what we'll talk about in the next section, integrity checks. Okay, in this unit, we talked about data errors, how to detect data errors. Um, the last part of it is an exercise. It's an optional practice exercise, and you can do that, and that is described in the next slide. Well, this is an optional exercise. Um, so the exercise or the assignment optional is to find a campaign contribution data for candidates running for state, not the US, but just for the state level offices in your state. And most of you are in Indiana, so Indiana. So when you find this campaign contribution data, try to identify problems you see in the actual data that you've downloaded. Jot down 3 instances of errors. How do you think these flaws were introduced? Like, are these because of the data entry, or this because of this data structure, or this because of the errors? Any kind. Just try to give some thought into it. That would kind of give you some practice in applying what you've learned in this particular unit. Thank you. I'll see you in the next unit, 2.6, where we'll talk about uh, conducting or performing data integrity checks.